Hi guys, let's discuss another Sadaqah Jariya today so that some people can get benefit from it and we can get something good also from this. Today we will discuss a firefighting pump station. Okay, so this is our pump station. Always anywhere in pump station, normally there is 5 pumps everywhere almost, depending on the budget, whoever what they want to do. There will be 2 jockey pumps always, and 2 electric pumps, and then 1 diesel pump. This is a normal configuration of any firefighting pump station. The purpose of the jockey pump is to maintain the pressure in the network. Now you will see after some time any one of this jockey pump will start running. Okay, and this is our network pressure. You can see, I think it is 111 psi. This is the network piping. Okay, now the set point for jockey pump is depends on the size of the project, the buildings, how many story building. As per that, the designer is deciding how much pressure is required in the network. So here we have 120 to 125 psi pressure we are maintaining. This pressure is maintained by jockey pump. Jockey pump will start 110 psi and cut off 120. So cut in 110 psi, cut off 120 psi, plus minus there is possibilities. Okay, now let's describe little bit about this pump station more. This is a suction pipe which is coming from the firefighting tank. So this is the suction line to the jockey pump, and this is, you can see, the discharge line with chuck valve to the network, underground network. The same exactly is the another jockey pump number 2. It is coming from suction line from the main suction header and then coming through gate valve, through flexible joint, pressure gauges, and then there is air vent, and then there is PRV, pressure relief valve. In case the pressure is increased, it will release the pressure. Then flexible. Why we put flexible? If there is any vibration in the pump, it will not transfer to the pipes, or if there is any vibration in the pipes, it will not transfer to the pump. So mainly the vibration will not transfer from the equipment to the pipes. So that's why we put the flexible joint. Even it is good for alignment purpose and these things. Then there is discharge line and check valve again to the network. And then there is pressure switches. You can see the stainless steel tube. This tube is going to the, you can see the jockey pump is now in operation. Is maintaining the pressure automatically. So this tube is going to the panel. Come on, let me show you something in good detail. This is the stainless steel tube which is going inside the panel. There is pressure switch inside the panel which is already adjusted, calibrated. These are the drain lines if you want to flush out the tube. It is good. You can see all the stainless steel tube is coming to the panels. In the panels there is pressure switches which is working as per the set points. So now come to the set points. As per this firefighting pump station, the jockey pump set point, as I explained to you, 110 psi to 120 psi, cut in and cut off. In case the jockey pump, in case there is fire or something, la samahalla, and the jockey pump is not able to maintain the pressure will go down. The jockey pump will keep running, but the pressure will go down. So in that case, if the pressure goes to 85 psi as per our set points, so this electric pump will kick in, will cut in, it will start to build up the pressure to give the flow as required. This is the same suction header. This is the suction line with gate valve, pressure gauges, flexible joints, the same air vent, the same BRV, pressure release valve, and the same thing. Always in firefighting pumps, there is packing gland system, no mechanical seal, because packing gland is reliable and it will not damage immediately. But the mechanical seal can damage immediately. That's why mostly probably they are putting the packing gland system in these pumps. Then we have the discharge line, flexible coupling, as I explained to you, for vibration control, discharge line, pressure gauges, instruments, and then check valve. Check valve to avoid the pressure break from the network. And then we have gate valve and then the network. So this is the electric pump number 1, electric pump number 2. So in case one is not able to fulfill the pressure, the second pump will also start. So both will keep running to maintain the flow. In our case, we have 15,500 GPM should be maintained by these pumps. Okay, and these are the control panels for each pump, the same as stainless steel tubes. Okay, this is for the electric pump number 2, the control panels, all in auto. Now come to the point, in case there is fire and there is the fire happens in substation, La Samahalla or some other area, and the power is also failed the same time. So these 4 pumps cannot run, jockey pumps and electric pumps, because they are electric pumps. So in that case, if the pressure goes to 65 psi, in that case by the way, let me explain to you, the electric pump, there is no cut-off pressure. The cut-in is 85 psi and the diesel pump is 65 psi, and there is no cut-off pressure because that is the fire. So it will continue giving the pressure unless the fire is finished and the pressure build up, because if the pressure is dropped in the network, it will continue running. The same way, this is the suction header. You can see the PRV, and then this is the discharge. The suction is there. This is the suction, same air vent, and the same here discharge line. Then there is PRV going again to the suction. Okay, and this is the discharge line. Same, exactly the same thing. There is a check valve, and there are most. Okay, and there is a gate valve, and you can see the gate valve here, and then the network. Network, we have 2 loops. Okay, so 2 loop is going out from the building. It's underground network. Diesel engine, we are doing weekly test run, monthly test run, preventive maintenance, and there is 2 batteries, 2 kick-in system. Okay, this is John Crane diesel engine. Okay, and all Aurora pumps. Now coming to another good point, in case the pressure build up in the system, so there should be a relief from the network. The relief is here. You can see here, this is the main line, this is the bypass line, and this is the PRV, pressure regulating valve, mechanical type. Before we have electrical type, that we remove it, there was delay time issue, was not working properly. So we have 2 PRVs. One is this one, and one is this one. If you want to go in detail, just in another video we can go more details. So when the pressure is increased, this PRV will open at 145 to 150 psi. The pressure goes to 150 psi, this PRV will open to avoid any damages to the network. So it will stabilize the pressure. Okay, it's the same second PRV, and then the water will go. This pipeline is going back to the tank. The 2 pipeline, it is the network, and this 2 pipeline is going back to the tank. So in case the water is increase the pressure, the water will go back to the tank. And then we have flow meters, everything here, pressure indicator transmitter. This all is controlled by BMS. And then we have the flow meter, where you can see how much water is going out. Okay, so this all is about the firefighting pump station. A brief description about firefighting pump station. Now coming to the point, mostly the problem here, the maintenance problem which is coming, the leakage. Always there should be small dripping from the system, from the pump, from the gland. So we should keep eye on the packing gland. This is one thing. Another thing, the check valve. Sometimes the check valve start passing and you will feel that the network pressure is dropping. So we have to check the check valve. This check valve has been recently replaced because it was already damaged, it's not good, it's not maintaining the pressure. This is the old check valve which we already replaced it. So the main issue is there, the maintenance, like the diesel engine, change oil, change filter, air filters, and keep eye on the maintenance, all spark plugs, all the fuel injection system, fuel pump, and these things. So these are the main ideas of the of the firefighting pump station. This is the panel for the diesel, and then you can see here the network. This is the outside network. These are one loop, closed loop for the network. Okay, and you can see here the diesel tank. This is the diesel tank. Always should be at least 70% full in case of emergency, so diesel is available. Okay, thank you guys, thank you for watching. Like, subscribe, and press the bell icon and share. Okay, thank you, so more people can get benefit from this technical channel, which is a learning channel, Sadaqah Jariya. Okay, thank you guys, good luck.